Okay, section 4.4. This is titled Writing Linear Equations. So it starts off with a note. Linear equations do not have to be in slope-intercept form. Do you remember what slope-intercept form was? What does an equation look like if it's in slope-intercept form? Or can you think of it? Can you think of an example of an equation that would be in slope-intercept form? Well, it would have to be in that form. So if you were thinking of something like y equals 2x minus 5, or y equals 1/2 x plus 4, then you were on the right track. Because we've been working a lot with linear equations that were written exactly like this, in that form. Okay, but there's another useful form that we're going to talk about a lot in this video, in this lesson, in this section. So this is another one of these formulas that are up on my wall, my wall tattoos that might still be up on the wall. They're still up on the wall, at least in the year 2024. But so this is point-slope form. So linear equations can also be written, they can also sort of look like this, you know. And it goes y minus y1, or y sub 1, equals m times the quantity of x minus x1, or x sub 1. So this is like a subscript of a 1, and then same here. And so this is called point-slope form. Okay? And there's a very, very, very simple reason why this form is called point-slope form, similar to why this form was called slope-intercept form. Because in this form, whatever number is in this spot, your m, well, that's obviously your slope, just like up here, just like in a lot of situations, m, it represents slope. And the other thing is the x1 and the y1 together, so x1 comma y1, together they form an ordered pair, which is going to represent just any point on the line. So x1 and y1 together would represent any point that you could find on, you know, this line. Like if you graph this equation, it would become a line, and this x1 along together with y1 could be any point on the line. One quick note, okay? The y right here and the x are just going to be y and x, or x and y. Just like up here, you know, just like how this y and this x, you know, when you actually have a specific example of an equation, it's going to be x and y. Now, a really quick example, just to see like kind of what it looks like. This right here is an example of a random equation that's in point-slope form. So it goes y plus 2 equals 1/3 times the quantity of x minus 7. So if I wanted to kind of think about what all these numbers mean, you know, like if I wanted to say graph the line, well, 1/3, that would be like my m in the m spot. And so that would be the slope of the line. If I were to graph this line, 1/3 would be the slope. And then my x1 value, okay, so look at this, it goes x minus x1. So it looks like x minus 7. So it looks like x1 is 7. What's my y1? Is it 2? Or should you be noticing how in the form, in the you know, the actual official form, right, it goes y minus y1. So whatever y1 is, it has to fit into the form where it goes y minus y1. So technically, in this green equation, my y1 value is -2, because you could absolutely think of this as y minus -2, and that way it would kind of fit the form, like verbatim, okay? So in conclusion, I guess, if I were to graph this line or think about what this equation would look like in the plane, it would contain the point 7, -2, and it would have a slope of 1/3. So now some example problems. These are the type of questions, as far as, I guess kind of referring back to the title, writing linear equations. Like, you have to come up with the linear equation based on information given to you about the line, about the equation, about the line. Can we write it? Well, in this first example, I think it's really good, as at least as a comparison, to remind you that if what they are giving you is M and B, what does it say over here? When these are the things given to you to work with, you might as well plug them into which form? If these are the items that they're giving you for free, what is the form that takes, these ingredients? Isn't it like this form? So just as a reminder, before we really get into, utilizing this form, let's just remind you that, well, if these are the things you're given, you might as well plug them into that form, where the M obviously goes in for M, it's the slope, and the -2 obviously goes in for B, and that would represent the y-intercept. So if they actually, instead of M, if they just said slope, and instead of B, they said y-intercept, same situation. So pause the video if needed, as always, but let's move on to these situations. So, okay, what if they literally tell you that the slope equals 2, or just M equals 2, and that your line contains this point? So in this situation, I highly recommend using point slope form, because with point slope form, the perfect ingredients that you can know is a point and the slope. So here we go. At least this time, let's literally write down the original, what's the word? Blank form, Anyway, here's let's write down the form. And okay, so it's not that complicated, really. The 2 is going to get plugged in for M. The -1 gets plugged in. It's an x coordinate. Remember, a point is an x coordinate and a y coordinate. But they're not going to go in for x and y. They're going to go in for x1 and y1. Y is going to remain y, and x is going to remain x. So just like that. The 3 gets plugged in for y1, the 2 gets plugged in for m, and the -1 gets plugged in for x1. So yeah, this negative drops down, and this becomes like x minus -1. Okay? Now, it's kind of a key spot here in the problem, because it is possible just to stop right now. I know I have all these other boxing, so it seems like there's more steps, but there doesn't need to be. Right now, like once you literally have these numbers substituted in, technically you have an equation. If all the directions wanted was write an equation that satisfies these, these details, you could be done. But oftentimes the problem wants you to have your final answer in slope-intercept form. So even though oftentimes you can get away with stopping right here, or maybe even going like that step, just kind of, instead of it being like minus negative, just kind of make it into a plus. So this is the same thing. It's equal, like, so just saying x plus 1. So, I mean, maybe you could go like this one extra step to finish your answer in point slope form. But you can actually keep this going and have your final answer be in slope intercept form, which, remember, was this form. So all we have to do is first multiply the 2, and so we distribute the 2 to clear the parentheses. So 2 times x is 2x, 2 times positive 1 is positive 2. And then what do you think we have to do next, or last, to end up with the equation looking like this form? Hint, where y is all by itself. When we just need to add 3 to the other side to get y by itself. And so that's probably a more common final answer, and it's the final answer you need if the problem is specifically asking for slope-intercept form. But again, oftentimes you can stop there or there with point-slope form. Another example, I don't know if this is going to be all that different really. Feel free to pause the video and try this on your own first. But considering that they gave us the slope and a point, we're going to use this formula, this form, okay? And of course, where does negative 3/4 go? In for m. Where does the 8 go? In for x1. It's an x coordinate. Where does the negative 5 go? In for y1. So you'll notice here, I just kind of jumped in, instead of writing it out as minus, look, minus and then the negative 5, I can totally handle that, and I prefer myself just to write this as plus 5 right away. And so again, oftentimes, depending on what the directions are asking for, you can just stop here sometimes, or we can keep this going, distribute the negative 3/4. So negative 3/4 times x, well, negative 3/4 x, and then negative 3/4 times negative 8. If you need a calculator to help you do that, then, by all means, no shame in that. And then what's the last step? If we wanted to finish our problem, our equation, in slope-intercept form, well, we would just have to get y by itself. And that would be a good final answer. Maybe even a little better, arguably, than that. Okay, changing gears. Looks like we have a few problems that are going to be like this. Okay, so final phase of this, like the final level, the final progression of this section involves, well, what if this is what they give us? Fortunately here, they were literally giving us what we needed for this formula, like the slope. They gave us the slope for free and a point for free. Here, the situation is they're giving us 2 points. So what are we going to have to do with that? I mean, it'd be nice if we had just, 1 point. All we really need is 1 point as well as the slope. And if we have those things, we can throw them into there. So what do we have to do? What do we not have that we desperately need? The slope, okay? I mean, can we figure out the slope for ourselves? Of course we can. Just like this, which we've done in earlier lessons. In the very recent past. Like quite recently, we've talked about using this formula to calculate the slope. So it's the y coordinates up top, y2 minus y1, and then on the bottom, x2 minus x1. In fact, you might want to jot that down x1, y1, x2, y2. And then so letting this play out, 1 minus 9, well, that's negative 8. Negative 1 minus 3, well, that's negative 4. And then you're going to want to, reduce that or straight up divide it clean if possible. So your final slope is 2. Well, guess what? Now that we know m is 2, don't we have everything we need for point slope form? Yeah, of course we do. So we're going to obviously be plugging in 2 for m, and then we might as well just keep it going with the 3 and the 9 being our x1 and y1, right? I mean, theoretically or technically, we could actually choose either of these points for my formula. But what I usually say is, if we literally just got done calling 3 and 9 our x1 and y1, we might as well keep that going. But again, full disclosure, I want to give you all the full story. We could have picked -1 and +1 for you know what I mean? But here we go. So y minus 9 equals 2 times x minus 3. And once again, depending on what the directions are specifically asking for, oftentimes you can stop with that answer. Or we could just keep this going until it was written in y equals mx plus b form for our final answer. Okay, distribute the 2, and then add 9 to both sides, and -6 plus 9 is 3. Yeah. And again, pause the video as needed. In fact, speaking of pausing the video, these last couple examples, I know they might not be that different at all. Same situation. They're giving you 2 points that the line contains. So try doing it, and please pause the video and try doing those or this next one at a time, just like I did here. Okay, so you try it. All right, now that you've unpaused the video, right? Here's what the slope. You got to find the slope. So y2 minus y1 ends up being 2 over x2 minus x1, and then the simplified, reduced slope is 1/4. And then once again, you might as well just choose the first point, even though you could have picked the other one instead. And this is the final answer I got after distributing the 1/4 and then subtracting 5 from both sides. This would be a good final answer if what you were looking for was actually slope-intercept form. So nothing different there. Other than what you might need to use a calculator to multiply the 1/4. Again, let's see if this example. Once again, one more quick chance to pause the video if you want to try this yourself first. And okay, so we got to find the slope. y2 minus y1, ba-bam, all over x2 minus, and then the -5. So that's a -6. On the bottom, it becomes 15. Does this reduce? Of course. By the way, I think your calculator, if you have the right calculator, can actually reduce fractions for you as well. In fact, if you just plug all of the current calculators we use in 2024, if you use the N over D button, the fraction button, and literally typed that in all at one time, I think it would just spit back out -2/5 and have it reduced automatically with the answer it gives you. So these are some good details here that I'm including off the top of my head in this video. But okay, now that we know we have m, because again, to use, just one more quick reminder, in order to use that formula, point slope form, to write out an equation, all we need is the slope and 1 point. And now that we've gotten this, and we have 2 points to choose from, probably going to pick this one, you're good to go to use this formula. So y minus 5 equals m times x. Remember, technically it's minus 5, which I just immediately like to write as plus 5. And one more reminder, oftentimes that's as good of a final answer as any, but all too often you need to distribute the negative 2/5. Again, might need a calculator, no problem. And then to get y all by itself, add 5 over, and this would be probably the best final answer for the last example. And that pretty much does it for point slope form.